Hello, everyone. So I'm Olyvia from Avasia, and I head up marketing and product UX at Avasia. And this is my colleague, Prasad. He's the chief product officer and a co-founder as well. So today, as Bart said, we'll be talking about a use case of a healthcare system that we developed on Kubernetes. And all of the technology, the multi-cluster, and everything that we've been hearing today, we have a multi-cluster, multi-tenant orchestration platform called KubeSlice, and we built this healthcare system on KubeSlice that I will be describing a little bit. I'll start with presenting the use case, and then we'll go into the technology a bit as to how we did it. So, show of hands, how many of you have had or know about colonoscopy? Because this is, yes, so if you're above 45, you're required to have a colonoscopy now. We know how fun that is. So in this particular system that was built on Kubernetes, there was an AI model that was assisting a doctor to do colonoscopies in real time. So actually, I have a picture here. So it was like that. There was a bounding box that was telling a doctor that there is a suspicious polyp here, look at it. So the components of the system was we had edge servers, we had stuff running on cloud, a multi-cluster system, and we had the feed node, which is in the operating room, where all the data was being collected, sent to the AI model that's running on the edge, and then some processing and learning happening on the cloud. In addition to that, in addition to this AI, real-time AI detection system, there was also a workflow automation component that we had, where it was all hands-free. Talk about a hands-free system these days, right? So it was all NLP-driven, so the doctors would actually talk commands into the system. So when they see an AI model and they see a bounding box like this, they'll say, take a picture through voice, and the system takes a picture. And then the doctor will say, sessile polyp, or whatever medical terms that they use. And our workflow automation system was smart enough to understand all the medical terms, and then it was directly written into a report. So all of this, so talking about data and healthcare on Kubernetes, so the system that we developed needed to be very secure. It needed to perform with ultra low latency. What we mean by that is that the whole back and forth from capturing those video feeds from when the scope is inside your tummy into going to the AI model running at the edge and then going to the cloud and coming back, that whole round-trip latency needed to be less than 120 milliseconds. And then, we are capturing frame by frame, and then the model is learning and the model is detecting at the same time. That inter-frame latency needed to be 17 milliseconds. So there's a lot of processing, real-time processing. It needed to be secure. And then coming back to the whole topology, and before I get to this, I'd like to say that even last week, this was it was actually being used in New Delhi in India by Apollo Hospitals. Those of you are aware of the name, it's a big hospital brand, and with Airtel and AWS as partners. And also in the US, we had one of the largest ambulatory service providers, AmSurge, and together with Verizon, we tested all of this back and forth multi-cluster connectivity and the latencies and what enabled us to put a system together like this. And this is where we are going with the system, or where there will be multiple regional hospitals, and each room would have a feed node collecting data from the patients, and there'll be multiple edges that's processing the data. And in this hub and spoke model, there will be real-time inferencing for the doctors and the nurses, and also real-time voice processing as they, are recording their findings into a report. So this is the whole workflow automation part that I alluded to a little bit earlier, where the doctors would actually, as they are seeing those monitors and the bounding box, the green bounding box that's assisting them during a real-time colonoscopy, they're talking commands to the system and actually writing reports in real time by voice. And with that, I will hand it over to Prasad, who will talk about how this multi-cluster connectivity and communication happened, how we had a multi-tenant architecture where KubeSlice, our fundamental technology, how that creates a slice for every hospital, or how we create that isolation between, say, the voice and the AI and the voice and the video streaming data that's going back and forth.
Yeah. Thank you, Olyvia. So as Olyvia described, right, one of the foundational things which we have needed to do is that we needed to have a network which is L3 and above, right? So API-driven systems are not going to be possible. We needed to have RTP streaming. It needs to be encrypted all the way in. So, and essentially, ingress and egress works well, but not everything for the data side, right? So how do you bring about low latency east-west traffic rather than north-south traffic, right? That's one thing which we wanted to look into. And obviously, Kubernetes is necessary for us to be containerized up workloads. Nothing can be more easy than Kubernetes from an edge, and as well as feed node running small K3s and different shapes of this thing. One of the things which at the edge node we had to have processing using NVIDIA for our image kind of a thing. So CUDA core needed to be there, so that we need to have a dedicated nodes to make sure that we image process. And then the communication is very important for us because of as Olyvia described, interframe latency cannot be more than 17 milliseconds. And the overall round trip was, you realize that the scope is inside the body, right? And doctor has a mic'd up or a phone, which the Bluetooth is going to indicate if there is any bounding box or a detected polyp in there. So all that round trip is important for us, the system to work. So that's the reason why we built as latency is, as I described, image needs to be stored because you're constantly learning. In the cloud, we have a learning system which has already processed a whole bunch of images, but as in new images coming in, we are kind of constantly learning. And at the edge node is where the inferencing module sits. And then the feed node is actually detecting. So we actually have two screens. One screen is from the scope provider, whoever it is, Boston Scientific or whoever, there will be that. And then there is another screen wherein the bounding box is showing up so that at least the doctor is not distracted. So all of these things needed to have more data intense kind of a transport, right? So what we built is a KubeSlice, right, which is essentially a way of sharding the Kubernetes cluster, right, and then create a virtual cluster across multiple clusters. You have a cluster in the cloud, you have a cluster at the edge, and you have a cluster at the feed node, right? And all of these things are kind of forming how it needs to communicate to each of these, right? So obviously, everything has to be end-to-end encrypted because, HIPAA compliance, the different patient data which is going in there. Although a lot of these things are obfuscated, but you realize that when an image is there on top of it, a patient name shows up or something like that. We need to make sure that everything is kosher from a standpoint of encryption, storage, and all that stuff. Right. So tenancy is needed because different, either hospitals or different divisions let's say our first entry in colonoscopy doesn't mean to say upper GI versus lower GI. You can't use the same system. And then cardiology has other applications inside it. So the same hospital may have different divisions who are going to be using the same inferencing system. So you needed to have a tenancy associated with it. Am I running late? Sorry. I'm trying to make cognizant about the time. Obviously, if you look underneath the hood, the architecture from a slice standpoint, we actually have dual interfaces inside the pod. You have a CNI interface, which is essentially the lifecycle management of the cluster. But we also created something called an overlay interface. Right? Overlay interface is something which we use to have this real-time data growing across from pod to pod standpoint. And then, obviously, in order for the services to discover itself, we needed to have on the slice, what we call it as a slice is a kind of a way of describing. It's a CRD, it's an operator, everybody talks about it. In all the clusters, we have an operator running in it, which actually instantiates all the pods and then gives an address. The advantage which we wanted to take is that, we don't want it to have, IP address management across all these clusters. We wanted to get rid of all that IP address management. We need to be able to get the edges as fast as possible and not have a long life cycle with respect to addressing and all that stuff. So this overlay address gave us a much easier way of defining a slice, right? And there is a bunch of components. We have software-defined network built into the cluster. Not, there are different ways. So if the AWS and Verizon brings the edge, that's one way. Mac is another aspect, which with respect to Airtel, we are trying to use AWS Outpost as an edge, and then bring it up. AWS, with association with us, did this trial in India. But irrespective of what, we wanted to be self-sufficient in how we run these clusters, right? So that's the reason why we needed a better way of isolation, better network, which can do layer 3 and above. It can do RTP streaming. It doesn't have any firewalls or natting. So when you have a multi-cluster, you're actually creating a virtual cluster from a networking standpoint. So every pod on the slice is able to talk, be it in a cluster in cloud or edge or a feed node, right? So that's the most important thing from a latency standpoint, which you had to do, right? That's about it. If you look at our YAML file, because everybody started showing YAMLs, our YAML file is very simple, right? We have certain, doesn't show, right? Other than the PowerPoint. Okay. So we have a booth in SU46. If you want to see, I can show you all that there.
And I'd just like to add, we have, please check out cubeslice.io. I've open sourced a lot of our components and our tools. So, as someone said, go and start it, like it, use it, and please do reach out to us.